Hello everyone. Today we will be looking at another very interesting problem, which is rotate the array from right to left k times. So let's understand this problem a little bit more. So let's say, for example, if the input is given n is equal to 5 and the array is given as 1, 2, 3, 4 and 5, and let's say we have to rotate it 2 times, right? So the k is given as 2, right? So this is the input given. Let's see how the array will get rotated. So let me just write down the input. This is the original input that is given to us. Now let's say I am rotating this for the first time. So this is the first rotation. What will happen is this 5 will come towards the first index and rest of the elements will get shifted. So what we will get after the first rotation? We will get 5, 1, 2, 3 and 4. Now let's see what happens after second rotation. When we do the second rotation, then we'll do this one more time, right? So now the 4 will come to the first, rest of the element will get shifted. So if we do this, then 4, 5, 1, 2 and 3. So after these two rotations, the final answer that we'll get is this one. So this we have to return. I hope the question is now clear to everyone. So let's see what we'll do in the brute force. Let us look at an example. So let me take the same example again, 1, 2, 3, 4 and 5. Let us store this element in some temp variable. We will shift all the elements towards the right. So let's do that. Once we have stored the element in the temp variable, we will shift 4 here, 3 here, 2 here and 1 here. And at the final stage, we will simply copy the temp variable to the first position. So this will give us the first iteration. Now let's do the second iteration also. So in the second iteration, we will store 4 in the temp variable and then we'll do the same operation. So then we will shift all the elements to the one position right. So once we have done this, then 3 will come here, 2 will come here, 1 will come here, 5 will come here and then 4 will come here. So as you can see, like after doing this two operations, we have actually rotated the array. So let's write the code for this. We'll create a function rotate k, which will take array as an input and then k. Okay. Now first iterate over the k, because we have to rotate it k times, so we'll iterate over k. So we will go from 0 to k minus 1. After this, what is the first thing that we were doing? We were actually storing last one in the temp variable, right? So let's do that. So let's declare a temp variable and let's store array of len of array minus 1. So this will basically help me store the last element. Now let's the inner loop to basically shift all the elements towards right. So we'll simply run j from n minus 1 to 1, okay, and then we will simply say array of j is equal to array of j minus 1. And once we have finished it, we will simply replace array of 0 with temp. And this is the complete code for the brute force. Problem here is, if we look at the time complexity, so the time complexity for this particular solution is order of n into k, because we are iterating the array for each rotation that we want to do, right? So for each rotation, we are iterating over the complete array. Now let's see if we can optimize this solution. So for the optimized solution, let's make few observations. So let's take one more example. Let's say if the array was given as 1, 2, 3, 4, 5, 6 and 7, and let's say if k was given as 3. Let's try to do 3 iterations and let's see what happens. Okay, so after first iteration, what will be the state of array? It will be 7, 1, 2, 3, 4, 5 and 6. After the second iteration, it will be 6, 7, 1, 2, 3, 4 and 5. And after the third iteration, it will be 5, 6, 7, 1, 2, 3 and 4, right? So now this is our answer. So if we see the last array, we can make a clear observation. We are actually moving the last k elements towards the first position. And if you get this intuition, then the solution is pretty easy. Now just hear me out how we can solve it. So let's say if the array is given to us which is 1, 2, 3, 4, 5, 6, 7. Let's say the first step that we do is reverse the complete array. So this is the first step. We'll simply reverse the complete array. After this step, what we will get? We will get 7, 6, 5, 4, 3, 2 and 1. Then in the second step, let's say we will reverse first k elements. Okay. So once we do this step, then what we'll get? We will be reversing only these three elements. So we will get 5, 6 and 7 and rest will be same 4, 3, 2 and 1. And now in the third step, we will simply reverse last k minus 1 elements. And once we have done it, we will get 5, 6, 7, 1, 2, 3 and 4. And this is the exact answer that we get. So now once we have understood it, we can write the pseudocode for it. So we will simply declare one function, rotate k. It will take array as an input and k. Then we'll simply say, let's declare n, which is nothing but len of array. We'll simply say reverse array from 0 to n minus 1, right? Now once we have reversed the complete array, then we'll do second reverse from 0 to k, and then the third step is we will reverse array from k to n minus 1, and this is the complete code. So here you can ask me, okay, what will happen, let's say if k is greater than n? So you're right, for this case we will have to handle it separately. So what we will do is make k is equal to k percent n, so that it will never go out of the range, and with that small correction we have completed the code. Now can you guys tell me what is the time complexity and space complexity for this approach? So I can say the time complexity is nothing but order of n, because we are iterating the array 3 times, right? And the space complexity is actually order of 1. So with that, we have optimized our solution. I hope the solution for this problem is clear to everyone and you guys have enjoyed it. For more such content, please do consider subscribing. Till then, bye bye.